everyone, and welcome back to the Operations on the Real Numbers course. I'm Mrs. Cofield, and today we'll be discussing lesson number 14, and that is the applications of multiplication. Now we're going to go ahead and dig right in. Here we go. Now, you all know the main principle of multiplication, which says that you can multiply anything times anything. And over the last few days, that's exactly what we've been doing, multiplying anything times anything. We've talked about multiplying fractions, real numbers, we've multiplied decimals, mixed numbers, we've multiplied everything. But today, we're going to take a turn as we look into some real world problems in which you can apply what you know about multiplication. So let's go ahead and give it a try. Before we start, I need you to write down this main fact right here. It's called the main application of multiplication. There are two main applications of multiplication, and they are finding a total when you keep adding the same exact number a bunch of times. For example, 1 plus 1 plus 1 plus 1 plus 1. It's like adding that same number a bunch of times, right? And then number two, it's finding a quantity when you have the rate. And sometimes a rate sounds like miles per hour, something like that. We'll get to more examples like that, but let's go ahead and give it a try so you see exactly what I mean. Let's go. So, problem number 1. It says a circular running track is 2 miles long. If a person ran around the track 5 times, how many total miles did he run? Now remember, I said one of those applications is a total when you're adding the same thing a bunch of times. So in this case, we have a circular running track. How long is it? It's 2 miles long, right? But it says that person ran around that track 5 times. That means if you look at it, it's like 2 plus 2 plus 2 plus 2 plus 2. Woo! He was running for days, right? So as he's run all these miles, if you think about it, 2 plus 2 plus 2 plus 2 plus 2, we really don't have to do that. That's really just saying that's 2 5 times. So in other words, it's 5 times 2. That's multiplication. And 5 times 2, that's simple. That's 10. So to answer their question though, we're talking about miles. So he ran a total of 10 miles. So you want to make sure that whenever you get these type of real world questions, that you give them that real world answer as well. So the total number of miles he run is 10 miles. How simple is that? But because you guys are so awesome and you've been practicing so hard, we know that you can multiply anything times anything, right? So what if I took the same problem and changed up the numbers a little bit? Let's try it again and let's see you guys go at it. So it says a circular running track is 2 2/3 miles long. If a person ran around the track 5 times, how many total miles did he run? Now we know, like we said before, it's kind of like that repeated addition, right? And you keep adding that number over and over again. In other words, we know we can just multiply. So we're just going to cut to the chase and we're going to say it's 5 times 2 2/3. But whoa. What do we do with this guy right here? We have 5 times 2 2/3. Now y'all remember what we said about mixed numbers, right? We don't mess with those. That guy has to go. So what we're going to do is we're going to convert that. And once we convert it, we end up with 8/3. Now we're talking. We have 5 times 8/3. And how do we multiply a fraction times a whole number? Well, first of all, you must remember that 5 as a fraction is just 5 over 1. And now we have 5 over 1 times 8/3. And how do you do that? How do you multiply fractions? Yes, you got it. You multiply straight across. So 5 times 8, that gives us 40, and 1 times 3 is 3. We end up with 40/3. Are we done yet? No, not necessarily. And the reason why not is because we can convert that fraction back to a mixed number because that's what they gave us. So we want to give that back to them, okay? So once we divide to convert, you end up with 13 1/3. So again, I said it's important to make sure we answer the question because we're talking about real problems here, right? So once you write that out, and we know that it's in miles, the total number of miles he'd run is 13 1/3 miles. Beautiful. Now, let's change up the game a little bit, and let's see if you guys can tackle another one of these guys. Because you guys, as I say, guys are rocking and rolling, and I love it. So, let's read this one together. The temperature of an object is increasing 13 degrees per hour. How many degrees will the temperature increase in 9 hours? Great job for all my readers out there. So, we're seeing 13 degrees per hour. That's quite interesting. If you all remember when I talked about those two main applications of multiplication, I said that one of them, it talks about a rate. That 13 degrees per hour, that's what we call a rate. And when we say per hour, you think about that as per 1 hour. That means 13 degrees for every single hour, okay? So, here's what that's going to look like. We know that this is multiplication because it's 13 per hour. And how many hours are there? 9 hours. Therefore, it's multiplication. 13 times 9. And when you do 13 times 9, all you have to do is do it like you normally would, and you end up with 117. And we're going to put the degree symbol on there because we're talking about degrees of the temperature increasing. So, again, to answer the question out loud in English, the temperature will increase 117 degrees. Wow. How about that? Hey, we're going to do something that we just did a second ago. Because I know that you guys can multiply anything times anything, let's see what happens when we change these numbers up a little bit. Same question, new numbers. The temperature of an object is increasing 13 2/10 degrees per hour. How many degrees will the temperature increase in 9 3/10 hours? Wow. Okay, so we know that we're going to be multiplying because, again, we have that rate that says 13 2/10 degrees per every 1 hour, right? But how many hours are there now? There are 9 3/10 hours. So now we have to set up this multiplication. So we're going to say 13 2/10 times 9 3/10. And how do you multiply decimals? Does anyone out there remember? Well, that's the cool part. Remember, we don't even necessarily have to line up a decimal because you can multiply anything times anything. So when we multiply it out, here's what it's going to look like, okay? So we have our 13.2 times 9.3, and then you multiply as usual. You just keep going through all the regular steps. And when we get down to the end, this is what we end up with. But the question is, and this is the question I love, where do we place our decimal? Now, does anyone out there remember how we place our decimal for our final answer? Yes, you're going to count the amount of place values to the right of the decimals in our question. So let's go through and let's count them together, guys. I see 1 here and I see 1 here. That's a total of 2. So that means that there should be 2 numbers behind the decimal in your final answer as well. So counting from the back, there we go, just right there. It should be 122.76. In other words, 122 76 degrees. Okay? So this is the amount that the temperature is going to increase in that amount of time. The temperature will increase 122 76 degrees in 9 3/10 hours. Great work out there, everybody. And great work remembering how to multiply those decimals. All right, let's change up the game one more time and see what happens. All right, let's try it. How many total grams of fat are there in 7 candy bars if each candy bar has 5 grams of fat? Now, if you look at this one, that keyword in there again is total. This is similar to that first question we did, where it sounds like we're adding up that same thing over and over again, right? So in this case, we're adding up the amount of grams of fat in candy bars. So if we were to add it, we don't have to really go through and add it because we know that we can just multiply it, right? We're finding the total. So in other words, that would be 5 times 7? Because it's 5 grams of fat, and we're talking about 7 candy bars. And we know that 5 times 7 is just 35. So remember, we want to go through and answer the question in English. And what that will look like is, there is a total of 35 grams of fat in the candy bars. Great work. But I think you're on to me now, right? You know what we're about to do next. Same question, new numbers. Let's try it again, because you can multiply anything times anything. How many total grams of fat are there in 7 candy bars if each candy bar has 5 1/4 grams of fat? Now we know we're trying to add that same thing again, but we're not going to add, right? We're just going to go straight into the multiplication. What would that look like? Well, here we go. It's going to be 5 1/4 times 7. But remember what we said earlier. You see that mixed number right there? We don't rock with those. That guy has to go. So how do we convert it? We multiply. We say 4 times 5, that's 20. And then you add the 1, you end up with 21/4. Now that we can work with. 21/4 times 7 over 1. And remember, we said that because every whole number as a fraction is over 1, right? So now it's simple. All we have to do is multiply straight across. So once you do that, we end up with 147 over 4. Are we done yet? No. It's similar to like we said before. If they're going to give us something like this, as in like a fraction, we want to give them back a mixed number because that's what they originally gave us. So this time, let's do the conversion together, okay? Let's go through and divide. Once we divide, we have 4 into 147. 4 goes into 1. Well, it doesn't. So 4 goes into 14 3 times, and that's 12. You're going to subtract. You get 2. You bring down your 7. 4 goes into 27 6 times. 6 times 4 is 24. Now we can subtract again. We see that our remainder is 3. Now, once we do all that work, I like to draw these little lines right here to show my direction of how I'm going to get my mixed number. So that 36 is my whole number, and then it's 3/4. You see that there? I love that workflow. So recalling that fractions correspond to division, that's why we did it this way in order to convert it back to a mixed number. And now we know that our mixed number is 36 3/4, okay? So that was so beautiful. Now let's move forward and try a new problem. I hope you guys are ready. But before we do, you must answer the question in English. And to answer the question, there is a total of 36 3/4 grams of fat in the candy bars. Wonderful work, everybody. Woo! Now, let's move on. Here we go. Boom! Let's talk about cheese. Do you like du fromage? Well, that's the French version of cheese, by the way. Here we go. If cheese costs $8 per pound, how much would 3 pounds cost? Well, do you hear our rate that we're talking about? It says $8 per pound. So in this case, we're talking per 1 pound. So $8 per pound is our rate. And how many pounds are we talking about? We're talking about 3 pounds. So should I say it, or do you already know what we have to do? I think you know what we have to do. All we have to do is multiply. Woo! So let's go ahead and multiply 8 times 3. And y'all know what that is. That is 24. Now that we know that 8 times 3 is 24, let's go back and answer the question. How much would 3 pounds cost? Well, 3 pounds of cheese would cost $24. Now, I like that we're going to put that dollar sign on there because that's what we're talking about is dollars. If we're talking in terms of money, we want to give them back the symbols as well that represent what we're talking about, okay? So let's move on to another problem. In actuality, the same problem, but with different numbers. Why? You guessed it, because you can multiply anything times anything. So let's try it. Let's switch the game up on them, okay? If cheese costs $8.59 per pound, how much would 3.5 pounds cost? Now we already know automatically, right? We're talking about this rate. We have that rate now. It's $8.59 per pound. So that's per single pound, right? But now we have 3.5 pounds. So let's go ahead and just set up the multiplication because y'all know what it is. You already know. So 8.59 times 3.5 equals, look at this for a second though. Doesn't this look kind of interesting? How are we going to multiply a decimal times a mixed number? And then first of all, you know we don't even mess with the mixed numbers. Oh, I just thought of something. That 3.5, does anyone out there know what half is as a decimal? Wow, half as a decimal, 0.5. Yes, that's 5/10, okay? So yes, all we have to do is just change that 3.5 to 3.5, and then we can do something with this because it's just so much better and so much easier. We have 8.59 times 3.5 now. And like we just said a few moments ago, is that all we have to do is multiply as usual because you can multiply anything times anything. And when you do that, here's what it looks like. 8.59 times 3.5. And then you just go ahead. It doesn't even necessarily have to be lined up, but as long as you are multiplying as usual, we end up with 30065. And now for our favorite part, and that question being, where should our decimal go? Now, we have to go back to our original question, you know, the one with the decimals in it, and we have to count the amount of places behind the decimal in the question. That's going to be our indication of where we place our decimal point. So let's go through and count together. We have 1, 2, 3. We have 3 numbers behind the decimal. That means that in our final answer, there should be 3 numbers behind the decimal, counting from the right. 1, 2, 3, and boom. It goes right there. 30.065, right? So if that's our answer though, 30 and 65 thousandths. Remember though, we're talking about money. And the question was, how much would 3.5 pounds cost? Huh? Do you tell somebody it costs 30 and 65 thousandths cents? No. Usually when we talk about money and in cents, cents is usually like in our hundreds. So we're just gonna like, you know, keep it in the hundreds for now, okay? And we're gonna tell them that 3 pounds of cheese would cost $30.06. Sorry to the little thousand that got cut off. But if you want to get technical with it, you could say 30 and 65 thousandths, but let's just go with the money. $30.06. That's what you would pay at the store. Okay? Do y'all have any questions about these? Because I think you guys are doing a great job. And just using all those skills that you all had about multiplying, knowing you can multiply anything times anything, I commend you on the great amount of work you are doing. So, let's do a quick review. So we said today that there are 2 main applications of multiplication. And those 2 are, number 1, finding a total when you keep adding the same exact number a bunch of times. And then we skipped adding a bunch of times. We just multiplied, right? Because we know it's like repeated addition. And then number 2, it's finding a quantity when you have the rate. And remember, the rate sounded like something per something, okay? And that could be like per hour or per dollar or per whatever. But just look for those rates, and especially that word per, okay? So total and per. Great work! So, I hope that you guys have gained a lot again from today as we looked at these real world problems and talked about the applications of multiplication. I look forward to seeing you all on tomorrow. Have a wonderful day and take care.